Hi, welcome to the video tutorial for a lesson in the probability strand called Pepsi Challenge. There are 4 lessons in the probability strand and this is the last one. I've used this activity many times in science and I just thought we should include it as part of this Thinking Maths project because it really does probe your children's understanding of probability and probability as a model, how we can use probability and what does chance mean. And so I think you'll find it very, very interesting. It engages the pupils. It's a really good way of just testing and probing their understanding of probability. So the lesson starts with an image of 1 in 100-year floods. And you say to the pupils, what does 1 in 100-year floods actually mean? So obviously you've got the literal, i.e. once every 100 years. You've got the fact that it means it's rare. It doesn't happen very often. Some will say 1%. So obviously they know they're focusing on percentages. But this is really interesting because the people having to change this language because it's predicted on history, not on future occurrences. And actually, I think it's read somewhere on the programme on the Ridge of Hope, more or less, that every year there's a 64% chance that somewhere in this country there'll be 1 in 100-year floods. So the whole language of probability is difficult, is confusing, and I think children simply coming to situations for probability where it's just the 2 things, it's one of them, it's 1 out of 2, it's half. But we're not actually pushing them to develop their understanding of probability and modelling situations, probabilistic thinking. And this is a lesson in that. All the ones before have been building up to it. So you say, okay, there's another image of someone in a supermarket doing a blind taste test, and they've got 5 drinks. And you say, well, what's going on here? Start having a discussion, and at some point in the discussion, I will hold up these and say, we're going to do a taste test. What do you think is going to happen? What's this got to do with probability? And by now they listen, because I'll say to them, actually, at the end of the lesson, 2 people can take these away. And you say, who thinks they can tell the difference between Coke and Pepsi? And you always have children pick up the hands, and I say, well, I need 1 volunteer, so I'm just going to toss a coin. So you're already using probability. You say, okay, if it's heads, it's a boy. If it's tails, it's a girl. Oh, it's a boy. So if it's heads, it's a boy in that half the room. If it's and I go through that to actually eliminate, so I end up with just 1 boy or a girl, whichever it is. Say, okay, they're going to drink 5 drinks of Coke or Pepsi. How many do you think they should get right before, so that we know that they're knowing and they're not guessing? Because the premise of this lesson is we need to compare it to chance, i.e. guessing. And the children have never thought about that before. They often think coins, what happens with a coin 1 toss determines what happens next time. No, it's completely random. You could have 50 heads in a row. And I think some of the mind magicians on the telly have been great using this, and there's lovely examples you can give, and there's other ones in early lessons such as Roy Sullivan Jr., who was hit by lightning 6 times, which is the basis of one of the early probability lessons. So often some will say 2 out of 5, some will say 3 out of 5, and then there's a consensus that maybe they should have 4 or 5. Okay, if you think 4 or 5, we'll write that on the board, 4 or 5 right. So the child goes out and you actually pour a drink in here, Coke or Pepsi. The class decide, they love it, the class decide, the child comes in and tastes it and thinks, oh, Pepsi. They go out and they do it again 4 times, and at the end you reveal to them how many they've got right. And it's very rare that they get as many as they predicted. Usually they only get 2 out of 5, and it's a bit of a joke. And you say, well, hang on, could they have been guessing? Yeah. So if we know if they're guessing, we can work out and compare real results of someone who thinks they know with the chances of someone guessing. And you say, well, how could we do this trial to find out the chance of someone guessing? What could we use? And at that point, I let them have a chat, and I put an image of someone tossing coins on the board. Because what you're asking to think about is, if you toss a coin, there's only 2 options, and that's the same as right or wrong. So we have a bit of discussion, and sometimes they'll realise that, others they won't, and you'll say, well, hang on, could we use a coin? What could it be? Heads or tails? Oh, it's heads. Oh, you had tails. So is that the same as guessing? You either right or wrong. Heads you're right, tails you're wrong. Oh, yeah. So actually, you're going to get a cup, and you've got 5 coins in the cup. Okay? Head, 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 head. Oh, there's 6 coins in here, but 5 of them are heads. 5 heads. What's the chances of that? Oh, you've got lucky coins, sir, like the last lesson we did. 5 heads, I've guessed correct. Is that the same as him doing that? Let's do it again. 5 tails. I guessed all wrong. Can we model this to see the chances of someone guessing using coins instead of doing lots of taste tests? Because I'd like to give these to you. So you're introducing the scenario that someone's made a choice. We don't know if they're guessing or not, and the only way we can compare it is working out the chances of that happening by chance alone. So this is where the coin toss comes in. So each group gets a cup with 5 coins in, and they do it 10 times, and they write down how many heads they got out of the 5. So by now, the pupils have thrown the 5 coins 10 times, and they've got results like this. And as they say to them, I'm going to ask you ultimately there's several questions you can answer, but one question is, based on your results, what do you think the chances are of getting 4 or 5 right by guessing? Knowing that they did it, you don't tell them this, you say, how did you work it out, and get it to explain to you. But they did it 10 times, and it might be that only once do they get 4 or 5 out of 5. So 1 out of 10 is 10%. Say, okay, each group, each pair, tell me how you worked it out. Oh, if we threw 3 lots of 4 out of 5, 3 over 10, we did it 10 times, is 30%. So what you ask the people to do is call out their percentage. So what you'll get is some will call out 10%, some will call out 0%, some will call out 30%, some will call out 40%, several will call out 20%, several will call out 20%, right? Some will call out 50%, 0, 10%. And you say, what are the chances of getting 4 or 5 right by guessing? What do you think it is? Someone will say, we'll find the average. Someone will say, well, there's lots with 20%, it must be 20%. You say, well, it could be 50. You say, well, we don't know what it is. It depends on the coins, depends who's throwing it. So at this point, actually they're really confused because everybody's results are different. And you say, well, what could we do? Let them have a discussion, see what they say, and then say, well, okay, why don't we just add everyone's results together? So, you might have 8 groups, say. You say, okay, group 1, how many times did you throw it? Oh, 10 times. Group 2, 10 times. That's 20 altogether. So what you're doing is you're accumulating the results. 40, 50, 60, 70, 80, and so on. And you say, okay, we've now done this 80, 100 times. Why don't we see what happens when we add everyone's results together? So, group 1, how many did you get? Oh, we got 1. We only got 4 or 5 times once. We got 1. We got 4. So, well, hang on, we need to add these up as well. So that's 1, that's 2, right? 2 out of 20, that's 6 out of 30. We got 3, that's 9 out of 40. We got 1, that's 10 out of 50. We got 4, that's 14 out of 60. We got 2, that's 16 out of 70. We got another 2, that's 18 out of 80. And you can see the results are increasing, but they say, okay, let's work out the probability. 10%, 10%. By the time you get to here, it's about 20%. The actual probability of getting 4 or 5 right by guessing is 18%. But what's interesting is the children have never thought about cumulative probability before, what happens when we add everyone's results together. So the results go from 10, 10, they vary, and end up at 20. So what you say to them is, what's going on with the numbers? Why are the numbers changing? What's happening when we're increasing, I would never say increasing the sample size, but what's happening when we're adding more and more and more results? When everybody does it, there's something going on with the numbers. Then, you get, if you've got time, get them to plot the graph, or you plot the graph, because often what happens here is the graph, so if this is say 50%, depending on how you choose your results, it could have started here, gone down and done that, or started here, gone up and gone down, where this is about 20%. And you say to the kids, what's going on with that graph? What does it mean? We threw it lots of times here. What's this graph telling us? It's this meaning in the numbers again. This means there's a 20% chance of getting 4 or 5 right by guessing. What does that mean? You've got a 20, is that a high chance? What does the shape of this graph tell you? Because ultimately you're challenging them to think about the experimental probability approaches a theoretical probability when the sample size gets large enough. It's a very, very rich task. Some groups I don't get onto the graph. It's nice, even if they don't draw it, for you to draw it, to say to them, what does this graph mean? The idea the probability is changing as the sample size is increasing. And what does the 20% actually mean? If we did it, if someone came in and got them all right, does that mean they know? No, there's a 20% chance of guessing. We can compare it to a benchmark. Now, there are several question sheets that go with the probability lessons, and you can choose when to use these. There's one with this that's like a talking heads, where people are talking about a treatment, and someone says, oh, this new treatment gives us a 60% chance of a full cure. And someone said, well, that's just like tossing a coin. The next person said, well, I wonder what the chance of the chance of a cure with the old treatment was. Someone says, what would happen if there was no treatment at all? So obviously you're moving into areas of science and medical testing, but it's this understanding of probability in their lives and how to apply it that we're challenging them with. This really is a challenging lesson, but it's really fun, and it really makes them think about probability and patterns in data.